Gold is a simple element. It is a dense, yellow metal known to science as Au. Yet, from this simplicity springs immense complexity. For millennia, its unique properties have captivated humanity. It does not rust or tarnish, making it a symbol of permanence in a transient world. Its brilliant luster has adorned kings. Its brilliant luster has adorned queens. Its excellent conductivity powers the sophisticated electronics that define our modern age. People have long turned to gold as a store of value. People have long turned to gold as a safe harbor during economic storms. People have long turned to gold as a universal standard of wealth that transcends borders and cultures. This enduring appeal makes understanding its origins more critical than ever. The world's relationship with gold can be understood through two key numbers. To grasp the scale of the gold market, we must first look at the planet's total endowment. Geologists estimate that the Earth's crust contains vast quantities of gold, but most of it is dispersed in such minuscule concentrations that it is not economically viable to extract. The amount that is considered recoverable with current technology, known as reserves, is estimated to be around 57,000 tons. The gold that has already been brought to the surface, the roughly 212,582 tons of above-ground stock, is where the story gets even more interesting. This vast hoard is not sitting idle. It is distributed across various sectors that define its utility and value. The largest portion, nearly half of the total, is held in the form of jewelry, accounting for approximately 95,547 tons. Finally, a significant portion is held by central banks at roughly 35,715 tons, and about 34,803 tons are used in industry. The annual flow of new gold into the global market is geographically concentrated, with a handful of countries dominating production. For over a decade, China has held the top spot as the world's largest gold producer. In a typical year, China extracts over 370 tons, accounting for more than 11% of the global total. This output is driven by a combination of state-owned enterprises and a large, established mining industry. Following China, a tight-knit group of nations forms the next tier of major producers. Australia and Russia consistently vie for the second and third positions, each contributing around 320 to 330 tons annually. Australia's production is centered in Western Australia and benefits from advanced mining technology. Russia has been increasing output with new projects in Siberia and the Far East, and production is also a strategic priority. North America remains a powerhouse in gold production, with Canada and the United States ranking among the top 5. Canada produces about 200 tons per year. The U.S. slightly less at around 170, largely from Nevada's Carlin Trend. Beyond these, countries like Ghana, Uzbekistan, Indonesia, Mexico, and South Africa contribute significantly, though South Africa's output has declined due to deep, costly mines. The journey of gold from a geological anomaly to a refined bullion bar is a long and methodical process, best understood as a 7-stage life cycle. The first stage is exploration, the modern-day treasure hunt. Geologists use satellite imagery, geophysical surveys, and geochemical analysis to identify areas with potential deposits. Promising targets are drilled, and core samples analyzed to determine grade. Once viable, the project enters planning and permitting, designing pits or tunnels, plants, and tailings, while completing environmental and social impact assessments. With approvals, construction transforms remote land with roads, power lines, water, processing plants, offices, and worker housing. Heavy machinery is assembled on site. Mining extracts ore, processing crushes and separates gold, refining purifies it to investment-grade standards. Finally, closure and reclamation secure pits, remove buildings, and restore ecosystems. The loop closes on the miner's long odyssey. There are two primary methods for extracting gold ore from the earth: and the choice is dictated by the depth and geology of the deposit. Open-pit mining is most common when deposits are near surface. Layers of soil and overburden are removed, rock is blasted, and massive shovels load haul trucks. The result can be kilometers wide and hundreds of meters deep. Underground mining targets deeper ore via shafts and adits. Specialized equipment drills and blasts veins. Broken ore is hoisted or hauled by rail. It poses challenges in ventilation, ground stability, and worker safety. For low-grade ore, heap leaching uses dilute cyanide over crushed heaps. The pregnant solution is collected and gold recovered. Higher grades are milled to slurry and treated by gravity, flotation, or carbon in pulp. Together, these techniques sustain a steady supply across diverse geology. The extraction of gold, while economically lucrative, carries significant environmental risks that demand careful management. Open-pit mines permanently alter landscapes, creating vast pits and enormous piles of waste rock. Moving hundreds of tons per ounce consumes immense energy and generates substantial carbon emissions. Large volumes of water are used for dust suppression, processing, and cooling, straining local supplies. Cyanide use in leaching and milling poses serious risks if spills occur. Leaks or dam failures can release toxins into rivers and groundwater, devastating ecosystems and communities. Mercury, common in artisanal mining, forms amalgam with gold and releases toxic vapor when heated, entering the food chain. Mitigation includes dry stacking to improve stability and reduce failure risk. Companies are exploring less toxic chemicals to replace cyanide. Robust impact assessments and reclamation bonding are becoming standard to balance economic drive with ecological imperatives. The social landscape of gold mining is as complex and fraught with challenges as its environmental counterpart. Large mines create jobs, stimulate procurement, and pay taxes and royalties. Many invest in community development as part of a social license to operate. Yet influxes can fuel social disruption, inflation, and strain on resources. Displacement can erode livelihoods, culture, and heritage. Conflicts over land rights, water, and revenue sharing can escalate into unrest. Worker safety risks include rockfalls, equipment accidents, and silicosis. In artisanal sectors, lack of protection and mercury exposure make conditions perilous. Initiatives like the World Gold Council's Responsible Gold Mining Principles and Fairmind set human rights and benefit standards. Transparent engagement, fair labor, and grievance avenues aim for equitable outcomes. Not all the gold that enters the market each year is newly pulled from the ground. A significant portion comes from recycling, secondary supply. Old jewelry, discarded electronics, dental gold, and investor bars and coins all feed recycling. Recycled gold is around 1,200 to 1,300 tons annually, roughly 25 to 30% of supply. When prices rise, consumers sell jewelry to pawnbrokers and gold buyers. Items are collected, melted, refined, and returned to fine gold, recyclable indefinitely. Urban mining dismantles electronics and chemically extracts precious metals, adding supply and avoiding landfill impacts. Recycling uses a fraction of the energy and can emit less than 5% of the carbon of mined gold. More recycled supply reduces pressure to open new mines and lowers social environmental risks. As sustainability awareness grows, demand for recycled gold rises, fueling a more circular gold economy. As we look toward the future, the gold industry stands at a crossroads. Technology is a double-edged sword, unlocking new deposits while improving urban mining efficiency. Jewelry and investment remain pillars, while technology's demand for reliable connectors grows. Green energy, electric vehicles, and advanced telecoms will rely on gold's conductivity and corrosion resistance. Central bank accumulation remains a major driver. Transparency and sustainability are reshaping expectations across investors, consumers, and regulators. Traceability technologies like blockchain and responsible sourcing can command a premium and incentivize better practices. In conclusion, gold's story is one of enduring value and inherent tension. The data is clear, production is concentrated, life cycles are long, and costs can be high, but recycling and responsibility offer a path forward. The choice to care about its origin is a choice to balance our desires with our duties to the planet and its people.